In this video lecture, we are going to deal with the NFA to DFA conversion. Actually, the construction of NFA is very simpler than the construction of DFA. That is why we obviously construct NFA first. After that one, we will go for the conversion of corresponding NFA to the DFA. The important point over here is, why won't we keep it with NFA itself rather than DFA? In DFA, we have a unique transition for every input symbol in the corresponding sigma. But in NFA, we may have either 0 or 1 or more than one transition for a given input symbol for the given sigma. That means there are more possibilities or there are not at all a possibility. We have to remove that non-deterministic approach to deterministic approach, in which we will have a clear-cut idea to go for the given initial state to the accept state by using DFA rather than NFA. For that one, what we have is, given NFA is going to be represented by using capital M with capital Q, sigma, delta, Q naught, F as usual. Let's take a M dash which represents a corresponding DFA, in which we are going to convert into Q dash, sigma, delta dash, Q naught, capital F dash. Please compare these two tuples over here, where Q and Q dash, sigma and sigma, that means there is no change in sigma at all, delta and delta dash, and Q naught and Q naught. That means the initial state in the corresponding given NFA is treated as initial state in the DFA, in which we are going to perform the conversion. The final state F and F dash. In the transition table, the final states are indicated by placing a star next to the state represented in the corresponding transition table. Let's go for the procedure. Step 1. The initial state of NFA is taken as initial state of DFA that we are going to construct. Step 2. Apply every input symbol on initial state following the transition in the corresponding NFA. That means if Q naught on 0 have more than one possibilities, we are going to represent by using a set. Then we will simply convert this corresponding transition function to delta dash by using this notation. What we will simply do is, we will simply remove these commas over there and the corresponding set symbol with the array braces, so that all these states, individual states over here, are going to be represented as a single state by using this combination, and the corresponding by using array braces rather than set braces. Step 3. Apply every input symbol on the new states brought out in step 2 using the transition rule. Q0, Q1, Q2, Q3 to PQRS if and only if NFA has, that means within the NFA, if at all there is a possibility, we will simply convert that possibility into this. We will repeat this step 3 until there is no more new states are generated. That means we will do until there is no new state is generated. The final states of DFA are those states that contain at least one final state in NFA. If at all we are going to take the example, let's take an example in which we are going to design an NFA containing 0, 0 or 1, 1 as such. As we already seen in NFA design, that we are going to go for minimum string 0, 0 and 1, 1. After that one, applying step 2, For initial state we are going to represent all possible states, and same way for final state we are going to represent all final state, all transitions that are possible. By this we are going to construct a NFA for this one. We are going to simply convert corresponding given NFA to the DFA. The initial state in NFA is going to be treated as initial state in corresponding DFA. We are going to do the conversion by with the help of a transition table. First we will go for the Q0 on 0. What we have is Q0 and Q1. We are going to represent Q0 Q1 as a single state, and Q0 on 1 we have Q0 and also Q3. That means Q0 Q3. What we have is Q0 Q3. What we will do now is we will keep a Q data structure in which first we are going to insert Q0 Q1, after that one Q0 Q3. Every new state that is generated from the corresponding step 3, what we will simply do is step 3, what we will put it into a Q data structure, and we will take one by one after another one. What we have in next one is new state is Q0 Q1, which is the first new state that is inserted into the corresponding queue. We will take Q0 Q1, after that one Q0 Q1 on 0. That means Q0 on 0, Q1 on 0. What we have is Q0 Q1 Q2. Q1 Q0 Q1 on 1 we have Q0 Q3, which is not at all a new state, but Q0 Q1 Q2 is a new state. What we will simply do is we will add it to the corresponding queue. Same way, the corresponding next new state is Q0 Q3. We will do all those transitions Q0 Q3 on 0, Q0 Q1, which is already generated, Q0 Q3 on 1. What you have is Q0 Q3 Q4, which is a new state. After that one we have is Q0 Q1 Q2 is a new state. For this one, what we on 0 we have Q0 Q1 Q4, which is a new state, and Q0 Q1 Q2 on 1. What we have is Q0 Q3 Q4. The next new state is Q0 Q3 Q4. We will simply do the corresponding steps repeatedly until no new state is generated. After that one, what we will simply do is we will put a star before those states in which the corresponding given NFA has final state. Q2 and Q4 are final state. We will put star before those states in which that has at least one final state. Here it is Q2, here it is Q4, here it is Q4. That's why we are going to put Q4 star over there. Here we have both Q2 and Q4. That is how we are going to convert given NFA to the corresponding DFA. Thank you.